So welcome all. Now, today we're going to finish up the consumer theory. So you'll see. And remember what we have done in our previous class. We were dealing with, if you guys remember, so let me write this sort of, remember when we were thinking about the utility maximization problem and the expenditure minimization problem. So maybe I should write them down before I recall what we have done. So we said that the utility maximization problem we had, right? So in the utility maximization problem, for instance, we had the utility function. So let's do it. Basically, so this was the problem that we were solving, maximize this utility function, right? And then we were maximizing with respect to these guys, subject to the budget constraint. Because you'll see that today we're going to make references a lot to these problems. So this is the sort of the objective function. This is actually the constraint, right? So that's what we said. And then from here we got the demands. And the demands we have gotten, we call them what? Do you remember? Now I'm not going to ask, hoping that you know. They're a function of all the prices and I, right? So, and these demands are, basically we said that they're called what? So these demands we gave them. Today, hopefully you'll understand better why we call them. We call them Marshallian demands, right? And sometimes they're called uncompensated demands, okay? So Marshallian demands and uncompensated demand functions, actually, okay? And then we had this demand, and I remember when we put these demands back into the objective function, we were getting the value function, and here the value function was what? It was called? So when I put all these demands back into my objective function, it's called indirect utility function, right? So it's actually the indirect utility function. And we called it, remember, like V. V was a function of what? All the prices and income, right? And then this is going to be U bar, right? So we said that suppose this is U bar. And then we wrote down the dual, right? So it was the expenditure minimization problem. So it was, we were minimizing expenditure, U of x1, x2, xn. Oops, no, that's not the case, right? So we are minimizing the expenditure. Now we flip the constraint and the objective function. So minimize expenditure, right? So you want to minimize this. Again, these guys, with respect to these guys, subject to the, so you want to keep the utility level of the consumer the same, right? So it was U of x1, xn equals to U bar, right? Suppose the maximal utility level here was U bar, so I want to keep that constant. So I want to figure out what is the minimal amount of money I should spend, right, in order to reach that U bar level. Then we actually have demands, right, in this case, and here we call these demands what? You'll see that today, so let me start naming them like this. I'm going to call them x1c, okay? So these demand functions are functions of what? Prices and utility, okay? As I told you, I keep saying, I ask this, okay? So no, and you'll see that it's going to be pretty important. So this is X and C. So the reason why we put a C here, because we call them compensated demand functions, okay? These are called or Hicksian demands, okay? And that's the reason for this C. So here I can say these are called Marshallian or uncompensated, okay? Uncompensated demands, right? And then we have, so here we call them Hicksian due to John Hicks, right, the economist who found them. And these are called compensated demands, demand functions, okay? So we'll see why they're called compensated demand later. So just hold on to that for a little bit. And then the value function was what? Here, when we have these optimal guys, we put them back into our objective function. We get what we call the, it was indirect utility. Here it was called what? No, but it was called expenditure function, right? So it's called actually the expenditure function. Right? It was called the expenditure function, and expenditure function was a function of what? If I put these guys back into here, just think there is only P's and U bars, right? So prices and utility, right? And this is going to give actually I, right? So that's why they were actually dual of each other, okay? So now, but this is, of course, so this is, but the functional form is actually this, okay? And the indirect utility function is actually this guy, okay? Now, I actually promised you, but we didn't, so let me do it now. So I promised to tell you a little bit about some properties of this expenditure function, okay? So let me write these down. So properties of expenditure functions, okay? So properties of expenditure functions. So the first one is that you also have these in your book. So if you like have a look at the book, don't get, like confused, and I'll try to explain intuitively, mostly, what they mean. So basically, expenditure functions, okay, expenditure functions are homogeneous of degree, guess what, okay, in all prices. What do you think this is? Homogeneous of degree what? 0, 1, 2, 0? Okay, let's try to see. So remember, for the homogeneity, if a function, I want to check whether it's homogeneous or not, I was writing this function, right, P1, P2, Pn U bar, right? And what was I doing? I was multiplying all these arguments by T, right? And then I was checking what? T, and then I was checking whether this T pops out, right? And with what exponent, right? So it pops out T times, apparently, but we don't know what this is. Expenditure P1, P2, Pn, U bar, okay? So what do you think this is? What does this mean? If all prices, so whenever, in the most of the time utility theory, you can always go back to the two good case, okay? So suppose I double both of the prices, price of X and price of Y. What's going to happen? Expenditure will? Do you think my optimal bundle will change? If I double all the prices, I doubled price of X and I doubled price of Y. I doubled this guy and I make this guy double. I did not, remember this is expenditure function, so we're keeping the utility level the same, so we're not thinking about income or anything, right? We're looking for actually what income you need, right, to achieve that U bar level. Suppose I double PX and PY. What do you think? What's going to happen to my optimal bundle? Suppose I solve this with PX, PY, I got these demands, and now I have 2 PX and 2 PY. Do you think anything will change? What was the first order condition? Remember, it was MRS should be equal to PX over PY. So it's the same thing, right? So basically, because remember, why were we changing our optimal bundle? If one good is cheaper relative to the other, right? If things change here, the ratio of the prices, it didn't change. But of course, if I want to consume my previous bundle, now that bundle costs twice as much, right? Then my expenditure is going to double as well. So then this should be what? 1, right? So you see, you guys just figured this out. So this is actually one property, okay? Expenditure functions are homogeneous of degree 1 in all prices. Okay, and remember, whenever we are showing this homogeneity, we always say that for all t. It's not enough to show it just for doubling. You should show it for any possible, t, okay, that you multiply these arguments with. So this is basically t to the power 1. So apparently exponential functions are like this. Good. So you see, I told you that you guys would do it. Would get it immediately, so because you guys are smart, right? Now another one. So let's try to figure this out. Expenditure functions are non-decreasing in prices. Okay, so what does that mean? It means that when I take the derivative of this expenditure function with respect to any price, apparently it shouldn't be increasing, right? It shouldn't be decreasing, right? It should be either increasing or it should stay the same. So this derivative is when pi increases, this expenditure, positive. Right? So this derivative, this means that this derivative is positive, okay? But why do you think this is the case? Why? So it says that when price of one good increases, expenditure, either the best case it's going to stay the same or it's going to increase definitely. Why? Do you think this is correct? Yes. So but why? Why? So okay, so in this kind of, it might be a bit early, but it's good that we're planting the seeds now. So it might be a bit early, but you should start thinking like this. Maybe our friends from the math department or engineering department, they might be a little bit used to this way of thinking, but you guys are in the second year, so most of you, so it's perfectly fine. But let's try to get used to thinking like this, okay? Sometimes it's better to think the other way around and say that why it cannot happen, okay? Sometimes you might not be able to show this, but you might show that the other way is not possible, okay? So for instance, sometimes it's called, you try to come up with a contradiction, right, in a proof. So there are many ways of proving stuff, but here we're not doing the formal proofs, but it's very important to get the intuition, okay? So suppose, let's say that in the initial problem, when price of x was px, okay, suppose this was my optimal bundle, okay, so let's call this xc, and yc was my optimal bundle. Therefore my optimal expenditure, right, the minimal expenditure was what? Px times xc, right, py times yc, right? So this is my minimal expenditure. Apparently these are the optimal points, okay? So suppose these were the optimal bundle, okay? This was the optimal bundle. Now suppose my price increases. So let's say px prime is greater than px. Suppose I have now px prime. Suppose price of x increases, but expenditure is going to decrease, okay? So suppose I'm going to, let's call this E0. Suppose I'm going to have an expenditure level, which is, so let's say that px times, let's call this xc, I don't know, oh, now we have too many stuff, xc prime, okay? And then plus, so this is going to be px prime, py times yc prime, whatever the new optimal bundle is, okay? xc prime, yc prime, suppose. The price has changed, so I solve the expenditure minimization problem, I get the new optimal bundle, right? Optimal points, and then I figured out what is the value, right? What is the minimal value? So this is actually the case. Now, suppose, do you think E1 can be less than E0? Then if that is the case, what is problematic? So suppose if E1 was less than E0, remember I claimed that with these points I was getting the minimal expenditures. Then if with these xc prime and yc prime is making me spend less money than E0, then why didn't I choose them here in the first place, right? I should have chosen them. And the price was even smaller, so this expenditure would have been even less than this guy, right? So then apparently if such thing happens, then these guys cannot be optimal, right? So apparently, so you see that we actually say that if these guys are optimal, there is no way when these price increase that I could have, you know, like another guy. The best thing is that I can actually re-optimize stuff and somehow achieve the same expenditures. But if I want to consume these guys, it's going to cost more, definitely, right? Or my new optimal bundle might cost even, you know, like more than that, okay? So just keep this in your mind. That's why the other way around is not possible, right? When price increases, if expenditure decrease, then you get a contradiction, right? So initial bundle that you thought that was optimal wasn't optimal at all, okay? So that's why we actually say that they're not decreasing in prices, okay? So don't worry, just try to have this way of, you know, making an argument, okay?
Can you like write this down in like a few sentences?
Okay, so it's, of course, so let's write this. So let's say that if E1 is less than E0, okay? And then we can say that then when price of X was Px, when price of X was Px, you should have also chosen, let's not put it like this, but you could have, right? So you could, so this is, you could have chosen, right? So basically xc prime, yc prime, and spent less than E0, right? And remember, price was even less than E0, even, you know, like less, since Px was less than Px prime, okay? So basically, and spent less than E0, hence, you can say that hence, xc and yc cannot be optimal. So why didn't you choose these points? Then if they were, you know, very good, then you should have chosen them in the first place. So this is actually leading to a contradiction, so it's not possible, okay? Don't worry about it, just try to understand, you know, like the argument behind it, okay? And this is, actually the formal way of proving it is also like this, right? So you just write it down like that. And there is another one. So again, let's try to show this. So these expenditure functions are concave in prices. Expenditure functions are concave in prices. So what does that mean? It means that the second derivative of this expenditure function is what? For concavity, so it should be less than 0, right? Why? So let's say why it's concave. Remember, like concave function was a function like this, right? So we learned about it. We even learned, you know, what's a concave function in the 3-dimensional case, right? A dome is a concave function. Remember, that's what we said. Now, so concave in prices for every good I, okay? So why do you think this is the case? Why do you think this is the case? So I should also have written for every good I for the other one, but don't worry about it, okay? So why do you think this is the case? Why should that be concave? Remember, a concave function was something like this. So suppose I have x, I have f of x here, okay? So this was concave, right? So another way of seeing, so there are many definitions of concavity. One of them is the following. It means that the tangent line would always lie above the curve, okay? Another way of saying concavity is this, okay? So we showed it in different, we said that, oh, you take 2 points, right? You take the convex combination of them, and such. So another way of saying it is that the tangent line would always, you see, any tangent line would always lie about this curve. And for a convex function, if you want to, you know, like figure this out, for a convex function, this is convex. Now, if I look at the slopes, right, the tangent lines, they are above or below the curve. Below the curve, right? So this is one way of saying concavity or convexity. Okay, so just keep this in your mind. Now, let me try to show you why this is the case. Now, you guys help me. I'm going to draw this. So this is, so I'm going to put here Px, okay, price of x, and I'm going to put here the expenditure, let's call it P1. I'm going to put here P1, P2, Pn, U bar, okay? Now, this is actually, this expenditure function is something of what dimension? N plus 1, right? So it's but suppose, you know, now I'm plotting this, right, with respect on a two-dimensional representation because I want to see how P1 changes, how this expenditure function would change, okay? Now, fine, now let's try to see. Suppose initially price 1 was P1 tilde. Okay, let's say this was the case. And I solved my expenditure minimization problem with P1 tilde. I got all my optimal points. And then it turns out that the minimal expenditure, of course, is this. Okay, U bar. Suppose it's this point. Okay? And suppose when price 1 was P1 tilde, my optimal bundle is, let's say, X1 star. Or X1C, okay, X2C, X and C. Okay, so this was my optimal bundle, suppose. Now, suppose I want to increase my price. So if I keep on consuming my optimal bundle, my previous optimal bundle, how do you think my expenditure will change? Suppose now this is actually, you know, like suppose this was 2, now it's 4. Okay, so let's call this P1 double tilde. So if I want to consume exactly the same bundle, it's going to increase in what fashion? Exponentially, or it's going to increase. So I'm going to double. So this part, so the expenditure, if you would like to see, here P1 tilde X1C, right, P2 X2C, Pn, X and C. Right here, this is the case. Now, this is P1 double tilde. If I want to consume my original, right, bundle, it's going to be P1 double tilde X1C, P2 X2C. So the rest is not going to change, but only this part, right? So then we say that it's going to increase in what fashion? In a in a linear, right? So it's going to increase in a linear fashion. So if I want to consume my previous bundle, then it's going to increase like this. Okay, so if you want to see, right? So if I want to consume this, I'm consuming my original bundle. So these guys are all the same, just a number, right? Like a constant. But this guy and this is the same. But this guy is changing, okay? So you can think of it like y equals to a times x, right? So a here is my x1c, but my x is increasing, right? So it's going to change in a linear fashion. Ax plus, of course, some constant, right? M. So now, this is the case. But do you think it's going to be when price increases to P1 double tilde? Am I going to consume my old bundle? No, right? You're going to what? You guys are smart. Remember, what were you doing? You were re-optimizing, right? Because you know that, and remember, there were two effects. Oh, now good one is more expensive. There were two effects. What were they? Substitution effect and income. Once you were saying that, oh, this is now too expensive relative to other goods. Let me decrease my consumption of X1. And then you were saying that, and I'm now poorer, right? Price of X has increased. The amount of goods and services I can buy is now less. Now I'm poorer. If it's a normal good, I should decrease my expenditure, right? I should decrease my consumption, right? So basically we were re-optimizing. So this is the worst we could do, but we could do better. That's why the optimal point, the expenditure function, should be somewhere like this, right? It doesn't have to be on here, probably it's somewhere below, right? So that's why we actually say that this is the true one. So this is P1, P2, okay, P and U bar. And this guy is going to be, this is not exactly, right? So this guy is the linear version of it. So it's not the optimal, it's not the value function, but this is the one, let's call this P1 times X1C, P2 times X2C plus dot, 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 right? Pn times X and C, right? You keep consuming your previous bundle, okay? So basically that's why the optimal, the minimal expenditure is probably not this much, but it's less. Definitely, it's always less than that. That's why the curve should be below this linear line, okay? The curve should be below this linear line, and at this point they should be tangent, because we know that at P1 tilde, this is the optimal bundle, right? So basically that is the case, okay? So just keep this in your mind, and these are concave in prices, okay? So just keep this in your mind. Now, so basically now what we are going to do, you'll see why we need this guy. But remember, in the beginning of this course, I told you that, okay, we're going to learn, this is our demand curve that we have seen in Econ 101. So what lies behind this demand curve, right? So that we learned, so we actually recovered this demand curve, okay? But here I kept saying demand function, okay? So like, I mean, it's not that important, but for instance, the difference between them is actually, it is important, but sometimes we use them interchangeably. Suppose this is the demand function, right? So it's a function of, suppose I have two goods, X and Y. So Px, Py, and if it's the Marshallian demand, income, right? So this is what we call a demand function, okay? Because it is not only a function of the price of that good, but also the price of other goods and your income, right? So we know that what is a demand curve that you have seen? So in order to draw this guy, for instance, what do I have to do? I have to keep, right? I have to keep which guys? Constant, right? So this is basically, I want to here, I'm looking at the optimal amount of consumption of X, right? The relationship between your consumption of X, right? And price of X. So basically, I want to look at the relationship between this guy and this guy. But we know that this is a function of 3 arguments, right? So if I want to draw that, I need a 4-dimensional diagram, right? But here, I only have 2 dimensions. In order to represent it on a 2-dimensional, diagram, what do I need to do? I need to keep these guys constant, right? It's exactly, so remember in 101 they never tell you this. They tell you this ceteris or ceteris paribus assumption, holding other things the same. When price of good X increases, quantity demanded of that good X decreases, right? So basically that is called the demand curve, okay? So when you keep these guys constant and you only look at the relationship between this guy and this guy, then we call it the demand curve, okay? But most of the time we're going to use it interchangeably, okay? But just keep this in your mind, okay? So here, the one that gives you this relationship is called a demand curve, okay? And basically, and here on the demand curve, holding, remember, everything else constant. And what are these everything else? This, ceteris paribus, ceteris paribus. So this everything else is this, as you guys told me. Hocam, price of Y should be held constant. Income should be held constant. What else?
Future expectations.
Okay, so we have like future expectations and such, but suppose this is, you don't have any expectations in this case. So what else? We're also holding something else constant as well. Okay, so let's say there is no, he's talking about expectation. Okay, we hold everything time, like expectation, but there is something else. Remember this, what determines this functional form, x star? Remember, we got these x stars, right, from different functional forms. What determines? Whether it's Cobb-Douglas, this x star was something different. It was CES, this x star was different. So actually we're holding the functional form, the utility, the preferences of the consumer the same as well, okay? So just keep this in your mind. In this everything else, you also have this functional form. Functional form of x is held constant. So basically, and what does that mean? X star is held constant. It means that preferences, right? So your tastes are also held constant, are being held constant, okay? So this is the case, okay? Now, so just keep this in your mind, and this is how we get the demand curve. So now let's try to get it graphically, okay? So probably you did this, you might have done this in Econ 101, but in case, like you didn't and you haven't taken any introductory Econ course for our engineer friends or people from math or other departments, okay? So it's, let's actually try to get the demand curve, okay? So basically, this is, suppose, now we know that, you see that apparently it turns out, even when I first took my introductory Econ course, I didn't know, but apparently all these points on this demand curve are coming from a utility maximization sort of. It's like as if they're coming from a utility maximization problem that has been solved for this price level, for instance, px, okay? I solve for my x star, I put it here. For this level of px prime, I solve my problem, I get my optimal consumption, and I put that on that demand curve, okay? Apparently, that was the case. So now let's show that. So this is going to be x, this is going to be y here, and I'm going to put, again, x, but I'm going to put px, right? I want to express everything on a different diagram. So now I'm going to keep decreasing the price. So what's going to happen? Suppose initially I have this. So now you're going to see your professor's, great drawing skills. But I did a good job in the substitution and income effect. You'll see when you try to draw them. So, okay, so this is basically, suppose I call this x star, okay? And let's call this U1, let's call this E1. It's always good to, label stuff, because you'll see that in some questions, you might need to draw a graph, you might need to explain what's going on there. So it's always good to, and don't forget to label your axes all the time, okay? Otherwise it doesn't mean anything. So suppose this is the case, and suppose my initial price is this, px. So the slope of this minus px over py, as you know, okay? And suppose x star is the optimal point. So x star is the optimal point when price is px, okay? So this is the point E1. Now I'm going to decrease the price. So let's do this. So when I'm going to decrease the price, what's going to happen? This budget line is going to rotate right outwards, right? So if I'm going to decrease the price, it's going to be like this. So here you say that, oh, hocam, so px prime is less than px. So this is minus px prime over py. okay? And then I'm going to look at my new optimal bundle. So let's call this U2. This is going to be E2. So X star, okay, X double star. Now, when price is a PX prime, which is lower, my optimal bundle here is X double star is here. I call this E2, okay? Now, let me decrease the price even further. So let's have this, okay? So this is, let's have this guy. And then PX double prime, okay? And then this is going to be minus PX double prime divided by PY, okay? And then U3, let's call this E3, okay? And then suppose this guy X3 star. And then when price is PX double prime, this is basically X3 star, okay? X3 star, so which is here, E3, okay? So when I connect all these points, this is going to be my demand curve. You see? So all those points on a demand curve, they're all optimal choices that you make, right? So this is basically the demand curve, and let's put this, now we know the fancy way, PX, PY, I. This is the Marshallian demand curve on which we keep PY and I constant, and also the preferences, tastes constant as well, okay? So this is basically the case. So if there's a change in income, what's going to happen? Remember, demand curve is going to shift, right? So it's going to shift like this, okay? It doesn't have to be parallel, but that's what we say. It's going to shift, okay? So basically, so this is the demand curve, okay? And let me make this distinction. Just keep this in your mind. So let's have this a remark. So if you have taken Econ 101, then you would know this. So this is the jargon that economists use, that we actually distinguish between an increase, or let's call it a change in demand, okay, versus a change in quantity demanded. Okay, and by the way, so like your friend, when I was saying, showing the relationship between PX and X, don't forget that this X is measuring the quantity, right? So in your Econ 101, you were writing quantity of X, but in this course we use both, X as good X and also X as the quantity of X, okay? So basically X measures the quantity. Okay, so a change in demand versus a change in quantity demanded. So a change in demand happens when this demand curve shifts. Okay, so a change in demand happens so when we say that when there is a shift. Okay, and when would you have a shift? If any of these factors that you kept the same, right, constant, if they change, then it's going to cause a shift in your demand curve, because here you have two dimensions. Any other thing changing, you cannot show it along this curve, but it has to shift, okay? So there's a shift, and any other, say, factor other than own price of good would cause this, okay? Now, a change in quantity demanded is different. A change in quantity demanded happens when there is a movement along the demand curve. Okay? So when there's a movement along the demand curve. So this happens when, right, so we're going to move along this demand curve only when this PX changes. Okay? So this happens when price of good, own price of that good, own price of good changes, okay? So this is, just keep this in your mind. This is a jargon economists use. We say when there's a shift in demand or when there's a change in demand, it means that the demand curve is shifting. When there's a change in quantity demanded, it means that we're moving along the demand curve. Okay, so these are different stuff. Okay, now, so this you guys figured out, you know, like what's going on in this demand curve. But I promised that I was going to link these guys, you know, like this guy and this guy. We did it mathematically, if you remember, when we solved the problem. But you know what Hicks did? So it's so what we can ask a very similar question like this. But let me ask you this. On E1, E2, E3, when I move along the demand curve, I'm keeping PY, I, the tastes, the preferences, and everything constant, yes? But what else is changing? What else is changing? So here, quantity, right, price changes. As price changes, quantity of X changing. So, but from E1 to E2, E3, what is different?
PX will be what?
Huh? Okay, so PX is changing. Yes, definitely. We said that. So PX is changing. What else? Someone said that. Utility, right? So here, utility is what? U1. Here, utility is what? U2. Here, utility is what? U3. Utility is increasing, right? So we never thought about this. But of course, because you're actually consuming more of the good. That's what we would expect, right? So you see that along this demand curve, utility level is changing. But what is constant? This I is constant, right? Nominal income. So we can ask a similar question. Remember, the idea was to get some sort of a relationship between PX and, you know, like quantity, price of X, and the quantity demanded of X, right? So we can ask a similar question saying that instead of keeping this I the same, let's keep utility the same, okay? And then let's try to give the guy, so if I want to keep, for instance, if I decrease my price, suppose initial price was this, I decrease my price to PX double prime, then in order to keep the utility the same, what should I do? Should I get money from the guy? I should give money to the guy. I should, when price decreases, I should get, right? Because the guy is better off, so I'm evil. I'm not going to let the guy to be better off. I should get money from the guy, right? And here, in order to keep his well-being the same, right? So I don't let him enjoy this, you know, like increase in real income. No, I'm not, okay? Or here, when price increases, I should give money to the guy, right? Because he is now worse off. I want to keep him at the same utility level. You can get a demand curve like this, right? Remember, because demand curve was showing us a relationship between PX and X star. Okay, I can, instead of holding I the same, I can keep utility the same and keep changing the guy's income, right? Because he needs here, when price of X is lower, he needs less income, right? And when price of X is higher, he needs more income to be at the same utility level, right? So now let's do that. So let's see. And that's why the demand curve that we're going to get from there is called compensated demand curve, because you keep compensating the guy, okay? So that's why the name comes, and that's why here this is uncompensated demand curve, because it's actually here you don't compensate the guy for changes in his real income, okay? So let's actually do that, and then we'll give a break, okay? Okay, so now let's do that. Basically, it's going to be, so I'm going to be loyal to this graph, okay? So let's do this. So this is going to be Y, this is going to be X, and I'll call this, remember this guy was called uncompensated demand curve or Marshallian. Okay? Now I'm going to have the Hicksian one, okay? And now you would see the link between those demand curves, okay? So basically, I'm going to put again PX here, I'm going to put again x here. So let me get that point there. Remember, so I had in one case, so it was blue, so let's be loyal to even that extent, okay? So I had, right, so this was my, let's call this U2. This was my point E2, and this was my x double star, okay? So this I had, and then I had it here, px prime. So this is x double star, so I'm going to call this E2. Now, because I'm going to do a little bit of a different exercise with this compensation thing, right? So if my income is just enough to achieve that utility level, then I know that, right, at this point, let's call this C2, okay? Now I'm going to change the price. So you see that my price here, and let me minus px prime over py. So initially my price is px prime. Now I'm going to decrease this price. I'm going to decrease this price to px double prime. What's going to happen? So I know what happens in the regular case, right? Now, as you guys told me, hocam, now the price of x is now lower. This guy's utility or real income or well-being has increased, right? So it has increased. So I should be getting some money from this guy, right? So that he would be on the same indifference curve. So it's going to be somewhere like here, let's say, right? Because now I have a new price. So the price is px double prime minus py, but I want to keep the guy on the same utility level. So let's actually do it like this. Okay, as I told you, I cheat. So then, okay. So like this, so suppose it's here. So I'm going to call this C3, not E3, C3. And I'm going to, and let me call this guy x double star, and also this is x double star C, okay? And I call this x double star C. This is also the compensated one. Now I decrease my price. So this is, I'm going to call this x double star triple star C. Do you think this is the same as x triple star there? This guy, is it equal to x triple star there? No, why? Is it more or less? Less, right? Why? Because remember, you said that, oh, now you feel richer, I'm going to get that money from you, right? I don't let you enjoy that extra, like real income. So I'm going to compensate you for the change, so in a negative way here, of course, right? Which means that you will be able to consume less, right, compared to this case. So these guys are not equal to each other, okay? So then this is going to be x star C, so x triple star C. So this is going to be the case when we have even a lower demand curve, okay? And I'm going to call this C3, okay? And then suppose I increase the price to Px, what's going to happen? I want the guy to be again on this indifference curve, but now there's a new price, right, ratio, which is here you can say Px over minus Px over Py right here. And then I'm going to call this C1. Okay, I go down, this is x star C, and then I go down here, this is x star C, and then this is px, and this is my C3. Do you think this guy is the same as x1 star, x star there? No, is it more or less? This time more, right? Because the guy was worse off. I gave the guy a little bit of income, right? So to make him on the same utility level, right? Is it clear? No? Okay. So suppose price of X increases, okay? Think of it like this. What happens? Do you feel happier or you feel bad? Right? Because the price of X has increased, so what happens is that you think that, oh, I'm worse off, right? But in this case, in this exercise, I don't let you to feel worse off. I'm like, oh, there is a decrease in your real income. I'm going to give you some money such that you can be on your initial indifference curve, okay? In this case, do you think you can consume more compared to that X star or less? More, right? So that's why this guy is not equal to this guy, okay? So don't, write it correctly. Because sometimes then you come and, hocam, but this says like this, I was stuck the whole weekend, I couldn't, and it's, you just wrote it incorrectly. Probably due to, it might be due to my, sometimes it gets messy, my mistake as well, but these guys are not equal, okay? But these are equal, okay? And as you told me that, hocam, this X star C is more than X star, right, that I have there, and this X triple star C is less than that X triple star there, okay? Keep this in your mind because I'm going to ask you a question. This, if you see, this is also giving me a relationship between the amount of X that you would like to consume and its price, right? But in a different fashion. So this guy here is called, when you connect these points, this guy is called compensated demand curve. It's a function of Px, Py, and right? Income was that guy, U bar, right? And here you keep this guy and this guy the same. What is changing along this demand curve? There you were keeping I the same, the nominal income the same, utility was changing. Here you keep utility the same, but do you have exactly the same income here, here, here? Nominal income? No, right? Because remember, I was getting some money from the guy, I was giving some money from the guy. Yes, so this is actually called, that's why it's called compensated, okay? That's why the name comes from. Compensated demand, so let's call this compensated demand curve, or sometimes it's called Hicksian, okay? Yes?
So we're only seeing the substitution effect in this.
Okay, that's very good. So, I told you that you guys are smart. You're ahead of me. So actually, I was going to come to that, but it's a very good observation. You see that what's happening here? Do I have any income effect going on in the second case? Right? Whenever there is, the guy feels better off, suppose price increases. You feel bad because you feel poorer. And then you say, oh, I feel poorer, and that was the income effect, right? But in this case, you eliminate it. You said the guy that, don't worry, any change in your real income well-being, I'm going to compensate you so that you wouldn't feel as if, anything has changed, okay? So basically, you are still at your utility level. Let's call this U bar, okay? Therefore, there is no income effect. So this is actually, you see that on the compensated demand curve, there is only the substitution effect, okay? Whereas on the uncompensated, the Marshallian, the ordinary demand curve, you would have two effects, right? Both the income effect and the substitution effect. Here, you don't have any income effect, you only have substitution effect, okay? So just keep this in your mind, so that's a good, very good observation. So here, let's say, so before this, just write compensated, so that you would have nice notes. Compensated demand curve. Okay? So this is how you would get the compensated. Did you get the idea how the guy, wanted to get it? Okay. So basically, and we know that on compensated demand curve, we only have substitution effect and no income effect because you compensate for it. No income effect, okay? And along here, the nominal income of the consumer is changing, okay? There, the nominal income of this guy, it stayed the same, but utility was changing. Here, utility stays the same, but nominal income is changing, okay? So just keep this in your mind. Yes?
Hocam, compensation dediğim şey olumlu bir şey değil mi? Yani limit comes.
But you see, it depends. You see, there were two cases. When price increases,
Yani C
it's good. When price decreases, I don't let the guy enjoy this extra stuff.
So making him not enjoy something is compensating.
Yeah, so as I said, it's called negative compensation.
Negative compensation.
Yeah. But you're right. So he's saying that, Hocam, compensating someone, usually you should be using it, when people are worse off. Yeah, in a positive way, but you are right. But here, that's why it can go both ways, okay? So this is basically the case. Now, this, again, we said that, so let me ask you this, and then we'll give a break so that I can get you guys some, goodies. So basically, but in this case, you guys figure this out. If I want to draw this guy and this guy, okay, on the same graph. So let's do this. So I'm going to get both of these guys on the same graph. So I am... Which one do you think is steeper? So I'm going to have px, px prime, px, ne yaptım ben ya? So px double prime, right? So it was like this. So let me draw the regular one, okay? So this is going to be, let's say, this. This is the regular one, x star, px, py, I. You keep these guys the same, okay? And I have all these points. Remember, this was x triple star, x double star, x star, okay? So I want to draw the compensated one. How should I draw this? Do you think I should draw it steeper or flatter than this guy? And don't forget that this E2 is equal to C2. So at this point, they should be the same, right? Steeper, flatter, steeper. Why?
Because at the high price levels, the quantity will be, low price levels.
So actually, the answer lies in here. Look. So this you figured out. But as you know, Essen was saying that you see that when things are actually, so when price increases, in the compensated case, you can consume more, right? So it's going to be somewhere here. X star C is somewhere here, right? At PX, it's going to be somewhere here. At this point, it's going to be the same. But for the case where price decreases, you're going to consume less, right? So, and it's going to be somewhere then X triple star C. It's going to be here, okay? And then I'm going to draw this compensated demand curve like this, PY U bar, okay? So you see that the slope of the compensated demand curve is steeper than the slope of the ordinary, right? The uncompensated, the Marshallian demand curve, okay? So this is basically the case. This is very important, but you see that, as I told you, you guys figure this out by yourselves, okay? Now let's give a 5-minute break, and you should tell me what you guys want so that I can get you guys some, I promised.